Hi folks, Ms. Javner here to talk more about oxidation reduction reactions. So if you want to title your notes that. Our goal today is to be able to identify where the process of oxidation and reduction is occurring in a chemical reaction using oxidation states. So hopefully your science isn't too rusty to learn about oxidation, which is rust. So we're first going to take a look at a video of copper wire being added to an aqueous solution of silver nitrate, which we're then going to write the equation for. So take a look and let's see what happens. So a solution of silver nitrate, solid copper wire is added. So what you see happening, if you see the kind of the silver substance forming on the copper wire, kind of flaky and crystalline. That's one observation I'm making. Another observation, it looks like the solution is starting to turn blue. So I see two things happening in this chemical reaction. I see a color change, the solution is turning blue, and I see a new solid forming on the copper wire that looks kind of crystally and flaky and is a white solid. If I can speed it up. So there you go. So let's see if we can write the molecular complete ionic and net ionic equation for the chemical reaction that you just saw in your notes between solid copper and aqueous silver nitrate, and then we will take a look together. So in my equation, I have copper solid plus silver nitrate aqueous. This is going to be a single replacement reaction where copper and silver are going to change places. I said copper was positive 2, so we should get copper to nitrate. Nitrate's negative 1, so I need 2 of them in my formula. This will be aqueous because it contains nitrate, which is always aqueous. And then silver will move out and be the new element on its own. And silver is not diatomic, so it's all by itself, and it is a solid metal. So that is what we have for our complete molecular. Now what I want to do is I want to go ahead and separate everything that's aqueous to turn it into my complete net ionic. But before I separate, I need to go ahead and balance my equation. So we're going to take a look at that here. So when I look at my equation, I have 2 nitrates on the left, so I need to put a 2 out in front over here. Now I have 2 silvers. So take a look at the complete and then we'll see how we did. All right, so this is what I got for my complete ionic equation. I took the 2 silver nitrates, I separated it, I left copper solid alone. I took my copper nitrate and I separated and left silver solid alone. So again, note how those subscripts are popping up to now be coefficients. Also notice how for each ion I included a charge that is required. So now what we're going to do is we're going to go ahead and cross out any spectator ions to form the net ionic. So it looks like nitrate is the only spectator, so what's left is going to be my net ionic equation. I can't cross copper solid and copper ions because those are not the same thing. So here is our final net ionic equation, copper solid plus 2 silver positive 1 ions, forming 2 silver solid and 1 copper positive 2 ion aqueous. So what we want to think about is how did copper solid here become copper positive 2? How did that happen? And how did silver ion become silver solid? So what's happening here is actually electrons are involved. So copper solid became copper positive 2 because it lost 2 electrons. That's where a positive charge comes from. My positive silver ion became a silver solid because it gained 1 electron. So what this is this is called an oxidation reduction reaction, or redox reaction for short. This is where a reaction in where electrons transfer from one reactant to the other. So oxidation is loss of electrons, and so that's what happened to copper. Copper solid turned into copper positive 2 because it lost 2 electrons. So we say that that is oxidation. So copper was oxidized. Reduction is gain of electrons. So in this reaction, we say that silver gained electrons. And one thing I'll just point out is in the net ionic equation, we had 2 silvers and 2 silver solids. Each silver gained 1 electron, but total they gained 2. So what we can see is that the electrons that were lost by copper here were then gained by the silver in this reaction. So there are, again, oxidation is the loss of electrons from one atom, and reduction is where the other atom accepts it in this oxidation-reduction reaction. There are 2 ways to remember this. One is oil rig, so oxidation is loss, reduction is gain of electrons. You could also use Leo the lion says grr. If you lose electrons, it's oxidized. If you gain electrons, it's reduction. So let's again look at this reaction a little bit more. So one thing that we do to figure out oxidation is we also look at the oxidation states. So copper as a solid here, and silver as a solid, free element by itself, both have an oxidation state of 0. My ions, my monatomic ions that I have here, have an oxidation state that's their charge. So each silver is positive 1, copper is positive 2 here. So what's happening in this process is silver is going from a positive 1 to 0. And so this is reduction. It had to gain electrons to do that. One way that I remember it is I think the phrase reduction in charge. Its charge was reduced. And so I know that that right away is reduction. And copper here went from a 0 oxidation state to a positive 2 oxidation state. So this was a loss of electrons, which is oxidation. So in an oxidation reduction, one atom will be oxidized and one atom will be reduced. Can't really have one without the other.